curriculum in this remarkably short video, we're going to very briefly cover text within games. So only a few things we need to say, so it won't take up too much time at all. So first of all, drawing text. We'll have a look at how text is drawn, say, within a word processor, first of all, then before going on to have a look at how we generally manage it within a game. So a lot of the fonts that we use and are familiar with, for example, the TrueType range of fonts, they are what known as an outline-based font. They describe how each of the characters looks in terms of a series of line or curve equations, and that describes the overall shape of each glyph of each character. And then you can render that onto a particular screen. The nice thing about the description is that it enables you to scale from small font sizes up to very large font sizes. And you can fill it with different ink colors and give it outlines and do lots of different things with it. So it's a very good, very capable way of actually specifying how something looks. We get a problem though if we want to use this within a game. We would have a problem if we're running games, say, at 50 times a second. We do not want 50 times a second to have to regenerate that particular bitmap of the glyph, because that would be needlessly expensive. It's a separate or different thing if you're doing it in terms of, say, a word processor, where you generate it once, you then store and retain that particular piece of text, a bitmap, until it needs to change. But in the game, we're constantly recreating our visual screen every single frame. So how do we get around it within a game? We actually get around it in the same way that early fonts got around it, that they were and are bitmap based. It means that there's a series of different font sizes that are used, and you'd have a whole collection of these, and you can download ones across different sizes. Effectively, it's an image. You can view it then as a 2D array. And if you want to pick a particular image, you'd go in, you'd have some rectangle that maps onto, for example, the character D, and you'd then copy that portion of the image out and draw it for the character D. It's very fast, it's quite efficient, unless you have more, I suppose, fancy graphics that can change, although you are confined to whatever predefined bitmap sizes that you have. So it generally doesn't scale up particularly well, though you can downsample generally reasonably well. And that's in essence what we will want to use within games by way of ensuring that we're rendering quickly. So we have a small exercise we can do now if we want to display some numeric text, so a series of digits like a score or a countdown timer. I actually have a challenge for you to consider. We assume here that we have an array of images, 10 images in total, where each image corresponds to digit 0 up to 9, so it's handily based on the index of a number. We can pull out the corresponding image for that digit. So I'd like you to spend 5 or 10 minutes, you can pause it here, and to develop a method where I could pass in the array of images, have, for example, our bitmap array of digits, and I call a method where I pass in an integer score, and given that integer score, you would then draw a series of bitmaps corresponding to that particular score. So you may want to pause here. It should only take about 5 or 10 minutes to do, and the next slide we'll have a look at a solution to that. So in terms of this solution, very compact. You can see the 7, 8, 9 lines of code that make it possible on the screen. Here we're calling a method drawScore, taking in the target integer score, and we're retaining a fragment. We're going to, if you like, strip off one digit each time and print it out, and then repeat until we've completely printed out the score. To do this, we're going to rely upon the properties of integer arithmetic, looking at the modulus and the divide operators. So in line 4, we're taking the modulus of the fragment with a value of 10, and effectively that strips off the rightmost digit, and we then draw that digit out. So small caveat in the sense that whilst we would normally write the digit from left to right, here we are drawing it the other way around from right to the left. Line 7 then is where we divide the fragment by 10. Because it's integer maths, we don't have any fractional component, and effectively that just strips off the last digit. And we have that part of a while loop, and we keep doing that until we've printed out the final digit. Very simple, very easy to do, and this gives us a mechanism whereby if we do want to display a score or a countdown, and we have a nice set of images that we want to use for it, then we can call this here. Need to be enriched a little bit in terms of providing an appropriate draw location that moves across for each digit that we want to draw, but that's about the only thing we have to add in. In terms of key takeaways then, text, either alphanumeric or alphabetic or numeric text, we're going to handle it really in the same way that we're handling images within the game. We'll have images for characters, for numbers, and we will control how we display these by way of displaying the various textual and digits that we want to provide to the user.